Tlte Technology and the United States Army, a Strategic Alignment Report. Section 1. Introduction. This report examines where Tedford technology, known as Tlte, aligns with the United States Army's highest priority modernization programs, as outlined in the Army's fiscal year 2027 budget and procurement documents. The central finding is this: Tlte does not replace the Army's existing systems. Instead, Tlte could become an enabling layer, connecting and strengthening them. The Army's FY 2027 documents are unusually important because they move beyond vague language about future technology. The Army is putting named programs and substantial requested dollars behind next-generation command and control, assured positioning, navigation and timing, counter-unmanned aerial systems, resilient autonomous agents, communications transport, and distributed decision-making. Section 2. The strongest match: Army next-generation command and control. The single strongest alignment for Tlte is with the Army's next-generation command and control program, referred to as NGC2. NGC2 is not one device or one traditional program. It is an ecosystem composed of 4 layers: applications, data, transport, and infrastructure. The Army has already moved the prototype through operational evaluations with the 4th and 25th Infantry Divisions, and as of July 31st, described NGC2 as ready to scale. That is remarkably important to the Tedford concept. The Army's FY 2027 procurement documents specifically say its NGC2 transport layer will incorporate satellite terminals, software-defined networking, line-of-sight communications, and multi-mission radios. The Army is therefore deliberately creating a heterogeneous communications environment rather than betting everything on one communications method. Where Tlte potentially enters this picture, the transceiver and repeater agent concept fits most naturally around the transport and infrastructure layers. The claimed Tedford architecture could potentially contribute local agent-to-agent communications, automatic rerouting, location and timing information, distributed situational awareness, connectivity between platforms, and communications continuity when individual paths disappear. That is extremely close to the underlying problem NGC2 is trying to solve. The important distinction: NGC2 is the Army's overall command and control architecture. Tlte would not be NGC2 itself. Tlte could potentially provide a resilient physical and networking component underneath or alongside portions of that architecture. Alignment rating: 9.5 out of 10. That is the strongest Army lane identified for Tlte. Section 3. Assured positioning, navigation, and timing. The next area of alignment is assured positioning, navigation, and timing, or APNT. The FY 2027 Army Procurement Book contains a dedicated line item for APNT. It includes mounted PNT, dismounted PNT, and alternate navigation. The Army's current program management description says its systems are intended to deliver trusted PNT in contested environments, distribute that PNT to other onboard systems, use modernized military GPS, and fuse additional PNT sources, including timing and alternate navigation technologies. That language matters. The Army is explicitly saying GPS alone is not enough. It wants multiple sources. That is precisely where the Tedford architecture should be positioned, not as a GPS replacement, but as an additional resilient source. GPS plus inertial systems, plus alternate navigation sources, plus trusted timing, plus Tedford distributed terrestrial agents equals another resilient source of position, time, and connectivity. That is a much stronger engineering proposition. The alternate navigation portion of the APNT line alone carries a FY 2027 base request of approximately $24.9 million, with broader APNT sublines substantially larger. One of the most valuable characteristics of the stated Tedford architecture is that the agents are not merely passive GPS receivers. The concept is that participating devices know where they are, exchange information, repeat information through neighboring agents, and maintain distributed awareness. If that can be technically demonstrated under GPS-denied or degraded conditions, That is an Army experiment TLTE should be pursuing immediately. Alignment rating, 9.5 out of 10, effectively tied with NGC2.
Section 4. Resilient Multi-Agent Autonomy. This section presents one of the most striking parallels between TLTE and Army research priorities. The Army explicitly describes research into resilient multi-agent autonomy, adaptive multi-agent systems, machine learning, system adaptability, resilience during deliberate interference, and autonomous operation under extreme or previously unmodeled adversarial conditions. FY 2027 specifically expands research into multi-agent learning adaptation. The resemblance between the problem the Army is describing and the distributed agent architecture of TLTE is substantial. The Tedford concept has always centered on individual transceiver and repeater agents, rather than a single centralized intelligence controlling everything. An agent receives information, evaluates information, communicates with surrounding agents, passes information onward, helps establish location and movement, reroutes information when another pathway disappears, and contributes to collective situational awareness. The Army is investigating resilient networks of autonomous systems that continue operating even when individual components or communications are disrupted. Where TLTE potentially adds something different, the Army's research seems heavily focused on the autonomy of vehicles, robots, and unmanned aerial systems themselves. Tedford's architecture could potentially supply the infrastructure of intelligent agents through which those autonomous objects communicate and coordinate. In other words, Army autonomous systems are the actors. Tedford agents are potentially part of the nervous system connecting the actors. Alignment rating, 9 out of 10. Section 5. Counter-UAS and Layered Air Defense. The Army's spending signals in this area are enormous. Its FY 2027 budget overview identifies $6.2 billion in multi-layered air defense investments, including approximately $994 million specifically for counter-small unmanned aerial systems. TLTE is not claiming to be the interceptor. It does not need to manufacture the missile. Its potentially valuable role occurs earlier in the engagement sequence. Detect, locate, identify, communicate, correlate, predict movement, warn, assign, deconflict, hand off to the appropriate response system. That is where the global mesh could potentially become useful. Imagine this scenario. A ground agent detects movement. A nearby agent verifies it. An aircraft agent sees it from another geometry. The command network receives the fused information. Friendly unmanned aircraft identity is checked. Civilian aircraft are separated. The threat track is continuously updated. An interceptor or electronic warfare system is then handed a better quality track. That is a much more plausible TLTE military role than attempting to compete directly against companies building interceptors. Alignment rating, 8.5 to 9 out of 10. Section 6. Navigation Warfare. Army documentation on navigation warfare is explicit. GPS will be disrupted in conflict. The Army describes navigation warfare as a system-of-systems approach designed to detect and geolocate GPS interference and determine the resulting effects on positioning, navigation, and timing across the battlefield. It contributes to fires, aviation, mission command, and electromagnetic warfare. That phrase, system of systems, is important for TLTE because Tedford is not really one isolated product either. It potentially ties together communications, position, navigation, timing, collision avoidance, situational awareness, autonomous systems, aircraft, vehicles, sensors, and command systems. That means TLTE's alternate navigation capability could potentially complement navigation warfare instead of competing against it. Navigation warfare tells the commander, GPS is compromised here. An alternate Tedford terrestrial mesh capability might someday answer, then use this surviving source. That is potentially a very strong military proposition, if demonstrated. Alignment rating, 9 out of 10. Section 7. Army Aviation and Unmanned Aircraft. The Army research material explicitly mentions structurally adaptive unmanned aerial systems, autonomous maneuvering, machine learning-based mission execution, and operations in hostile and cluttered conditions. A battlefield filled with helicopters, fixed-wing aircraft, small drones, loitering munitions, ground vehicles, friendly troops, autonomous systems, and enemy drones creates a deconfliction problem orders of magnitude more difficult than civilian aviation. A distributed system capable of exchanging location, direction, velocity, and intent has obvious conceptual relevance. The Tedford anti-collision technology could therefore potentially become more than an aircraft collision warning system. It could become one application running across the broader distributed agent infrastructure. Alignment rating, 8.5 out of 10. Section 8. Ground Maneuver and Combat Vehicles. This may be one of TLTE's underestimated strengths. NGC-2 is being designed specifically to connect tactical forces and give commanders better information faster. The Army is putting $2.9 billion into NGC-2 among its FY 2027 close combat investments, alongside combat vehicle modernization and other command and control priorities. Now place Tedford agents into Abrams tanks, Bradley replacements, Stryker vehicles, Joint Light Tactical Vehicles, robotic vehicles, supply vehicles, soldier equipment, unmanned aerial systems, and command posts. Every participant potentially becomes another information point. If TLTE's mesh really provides the resilience described, every additional equipped platform potentially strengthens rather than merely consumes the network. That is conceptually powerful. Alignment rating, 8.5 to 9 out of 10. Section 9. What the Army is actually trying to build. After reading the Army documents together, the Army is not merely buying a collection of radios and drones. The direction looks more like this: a distributed digital battlefield in which every sensor, soldier, vehicle, aircraft, drone, and commander can exchange useful information quickly enough for humans and autonomous systems to act on it, even under electronic attack. This is supported by the Army's simultaneous investment in NGC-2, Command and Control Transport, APNT, autonomous agents, counter-UAS, and resilient networking. And that is exactly why TLTE belongs in this conversation. Section 10. Where existing Army systems end and TLTE could begin. This is the most important strategic distinction in this entire report. The Army already has satellite communications, military radios, GPS, alternate navigation programs, sensors, command systems, artificial intelligence applications, unmanned aerial systems, counter-UAS, and sophisticated data networks. So TLTE should not walk into the Pentagon claiming we replace all this. That would make the pitch unnecessarily difficult. The better proposition is we connect these things and give them another resilient path. That potentially changes the acquisition conversation. Section 11. Appropriations, where the opportunity becomes financially significant. The Army's FY 2027 request is approximately $253 billion overall. Its procurement summary requests roughly $35.9 billion in discretionary procurement, with another major mandatory funding component shown in the FY 2027 plan. Within the areas closest to TLTE, NGC-2, approximately $2.9 billion highlighted in the Army budget. Counter-small UAS, approximately $994 million. Broader multi-layer air defense, approximately $6.2 billion. Assured PNT, multiple dedicated procurement lines. Command and Control Transport and Infrastructure, dedicated FY 2027 procurement restructuring and investment. Autonomous agent research, explicitly expanded in FY 2027. Those numbers must not be interpreted as money available to TLTE directly.
They demonstrate the size of the Army's commitment to the problem areas TLTE addresses. Section 12. Appropriations Status. There is also an important congressional qualification. The House Appropriations Committee has already approved its FY 2027 Defense Appropriations Act 34 to 27, with a stated discretionary allocation of approximately $1.072 trillion. Meanwhile, Congress has been working through a FY 2027 continuing resolution process, rather than having every regular FY 2027 appropriation completed. The Senate Appropriations Committee's current materials show the Continuing Appropriations Act of 2027 and Senate activity from August 7th and 8th. So the Army's FY 2027 numbers are highly informative about where Army leadership wants resources placed, but not every requested FY 2027 dollar should yet be treated as final enacted program authority. Section 13. Closing Summary. TLTE to Army Alignment Rankings. To summarize the alignment of TLTE technology with the Army's highest priority modernization programs, Next Generation Command and Control, 9.5 out of 10, the strongest lane identified. Assured Positioning, Navigation and Timing, 9.5 out of 10, effectively tied with NGC2. Resilient Multi-Agent Autonomy, 9 out of 10, one of the most striking technological parallels. Navigation Warfare, 9 out of 10, strong complementary positioning. Counter-UAS and Layered Air Defense, 8.5 to 9 out of 10, significant role in the engagement chain. Ground Maneuver and Combat Vehicles, 8.5 to 9 out of 10, an underestimated strength. Army Aviation and Unmanned Aircraft, 8.5 out of 10, relevant across the distributed agent infrastructure. The conclusion is clear. TLTE is not positioned to replace what the Army is building. It is positioned to connect it, strengthen it, and give it another resilient path across nearly every one of the Army's highest priority modernization programs simultaneously. End of report.